Hi, this is Melody Rondo, and we are going to look at graphing quadratic functions today. Our essential question, how do we graph quadratics using vertex form? And our learning target, I can graph a quadratic equation in vertex form. Here we go. All right, so we have the graph of a quadratic. We call that, it's a U-shaped curve. You can see kind of the U's in those curves. They're the red curve and the purple curve. Those are both kind of U-shaped. And we call them a parabola. Then we have parabolas can have a maximum or a minimum. So I'm going to add a little bit to the picture here. We have, for this first one, the red shape. At the ends of the graph, these would be essentially arrows, meaning it does continue forever. In the line or the curve continues forever and ever. In this case, for the red one, going up and up and up forever. And we would say this one, this opens up because we have the going forever and ever in the up direction. Then this point down here at the bottom, we call this the vertex. And I'm sorry, in terms of your notes, go ahead and just sketch a graph of this. You don't have to graph it perfectly. Just draw yourself a quick sketch in your notebooks. So yes, opens up. The point down here, in this case at the bottom, is called the vertex. And in this case, it is the minimum because it is the lowest value on the graph for the y value, lowest y value on the graph. And then for the other one over here, this one would continue forever and ever going down, going in this direction. So we would call this one opens down or downward. And then for this one, we still have that vertex. Here's the vertex for this one, for this parabola. And it's right there, that point. But in this case, that vertex is a maximum because it's the largest y value on the graph. It's as high as we can go. So that kind of gives you just a quick idea of what those graphs look like. And then we're going to talk a little more. So the vertex form of a quadratic is y equals a times the quantity x minus h squared, quantity squared, plus k. And from that, we have some important pieces of information. First of all, the reason it's called vertex form is because it shows us the vertex. So when your equation is written in this form, the vertex will be h, comma, k. And an important thing to take note of is that h will be the opposite of what it appears. So h, you'll notice it says in the equation minus h, but in the vertex it's a positive h. So it kind of does the opposite of what it appears in the equation. K stays the same. So k is the same. It's not constant, but k is a constant. It's just a number, and it does stay the same. So then we also have a values. So a values, that number in front of your parenthesis, this one right here, the number that's in front tells you something about the graph. The a, if it's positive a, then it tells you that the parabola, which is that U-shaped graph we saw a moment ago, opens up. And if it's negative a, then it tells you the parabola opens down. So positive a is up and negative a is down. Cool. And then we have something called the axis of symmetry, which I'm going to go back on the graph and point out for us. The axis of symmetry is an equation that is the equation of a vertical line. and it looks like this. It says x equals whatever your h is from your vertex. And I'm going to just make a note. This is the equation of a vertical line. All right, so I am going to go back, and so we can look at where the axis of symmetry would be. Oopsie. Well, there you go. That's okay. All right, so in these graphs, the axis of symmetry is the vertical line that divides your parabola in half. Oopsie. Well, I was doing pretty good. Right through there. So again, it divides the parabola in half. So what it does here is it gives us a mirror image. So everything on the right side of that line, it has to match everything on the left side of that line. And I'm just going to make a note that that is the axis of symmetry. It means it's symmetrical on both sides. So axis of symmetry. And then on the second graph over here, this one, we also have that axis of symmetry. Again, it goes right through the vertex and just cuts that parabola in half, or shows us the matchy sides. And again, that's called the axis of symmetry. Cool. So let's go forward. All those beautiful things we already wrote down. And all right, so our first few examples here, you might want to pause the video, take a minute and write these down, and then come back, and here's what we're going to do. We're going to find the vertex and state whether the parabola opens up or down. So just a reminder, the vertex is going to be h comma k, and it's basically the number. The h is the number in the parentheses with x, and the k is the number at the back. So for this first one, my vertex would be, I'm going to do h and k. Be super careful, because right here you can see here's the h and here's the k. H looks like it's -7, but it's going to do the opposite. So it's actually going to be +7 and +1. So it's just that h that does weird things. And then to decide if it opens up or down, I'm going to check the number in front of the parentheses. So I'm going to check this number right here, which is a 3. And I'm looking for, is that number positive or negative? Since that's a positive, we're going to say, I'm going to write a equals 3, so it opens up. If it opens up, that also means it has a minimum value. So it has a low point and then goes up and up and up forever. All right, for the next one, same thing, looking for the vertex. I'm looking at h and k. And this one, again, h is going to do the opposite. So even though it says +4, my vertex is going to be -4, and then k follows -3. My a value for this one is 1/2, which is positive. So that, again, means it opens up. Cool. Then let's go to the next one. Same idea here. Let's look at the vertex. That means I'm looking for h and k. And again, h is going to do the opposite of what it appears. So it says -5, so that means it's really 5. And then k is going to stay the same. On this one, my a value is -6, which means it's going to this opens down. Last one, again, looking for the vertex. Here's h and k. So I have -1. Remember, h does the opposite of what it shows. And then 6. And then my a value is -2/3. And because it's a negative, it's going to be opens down. Cool. Next couple examples here. So now we're going to actually graph the function. We're going to label the vertex and the axis of symmetry equation, and I'll show you that as we go. When we are graphing, we're going to start first and foremost with the vertex. So for this first one, here's h and here's k. That vertex would be 2, 3. Remember, H does the opposite of what it appears. So I'm going to go ahead and put that on my graph. Over 2, up 3. Whoopsie, up 3, not 2. Over 2, up 3. Fantastic. And then that is also where my axis of symmetry is going to go. So axis of symmetry is based on the vertex. It goes right through the vertex. It's a vertical line right through the vertex. And that equation is x equals whatever your h value was. So in this case, 2. And I will draw an arrow to it in a minute. Actually, I'll do it now. It's fine. X equals 2. That's this right here, axis of symmetry. Okay, and then to actually graph the parabola, we have our vertex. We can double check that the number in front says our parabola is going to open up, because this right here would be a positive 1. So I'm going to just make a note that it opens up. And then the last thing I just need one additional point. So I'm going to pick a number close to the x equals 2. You can pick any number you would like, but I'm going to pick something close to x equals 2. So I'm going to pick 3. But you could have picked 1 or whatever number you want, and I'm going to plug it in. So I'm going to basically build a quick little t-chart here. I'm going to do it over to the side, actually. And I'm going to plug in x equals 3. So I'm going to take my equation, y equals, and I'm going to put 3 minus 2 squared plus 3. And I'm going to solve that. 3 minus 2 gives me 1. And then I square it. So I get 1 plus 3, which equals 4. So my ordered pair that I'm going to plot on my graph is 3, 4. So I go over 3, 1, 2, 3, and up 1, 2, 3, 4. And I did not put I'm so sorry, guys. I just realized I didn't put my other part of the graph in the right place. Let me fix that. Oh my goodness gracious. Oh dear, dear, dear. Okay, let me try that again. The vertex is at 2, 3. 1, 2, 3. There we go. And the axis of symmetry is at x equals 2. Cool. And then now if I go over 3, up 4, that looks a little bit better. Cool. So I have my point there. The beautiful thing about the axis of symmetry is everything you have on the right side has to match the left side. So I'm going to match that point on the right, and I'm going to add a point on the left to match it. And then I connect the dots, and I make that U-shape graph like that. And that's graphing. Let's try the next one. So again, I'm going to start with my vertex. And the vertex I have is at -1, -2. Remember, h does the opposite of what it appears. See if I can graph this one correctly. -1, -2. Cool. And then my axis of symmetry is going to be x equals -1. It's whatever your h value was. And again, graphing it, it goes right through the vertex. And this one, and I'm going to go ahead and point to it. There it is right there. Cool. And then this one, I can double check my a value again is 1. So it's going to be opens up, because that a value, that number in front was a 1. So it's going to open up. Then the last thing I need in order to graph this is I need at least 1 point so I can do the mirror image, copy it on the other side of the axis of symmetry. Since my x was -1, this time I'm going to plug in 0. So I'm going to I just pick something close to the axis of symmetry. So I'm going to plug in 0. So I have y equals 0 plus 1 squared minus 2. And I get that's 1 squared minus 2. 1 squared is 1, so 1 minus 2, I get y equals not 2, -1. Okay. And I'm going to go ahead and graph that ordered pair of 0, -1. So over 0, down 1. And again, match it up to a point on the other side of the axis of symmetry and connect the dots. Nice smooth curve as best you can. And I'm going to redo that one since it went crazy there. And that finishes that graph. All right, so we're going to just do example 7. We're not going to worry about example 8 because example 7 is going to give us a chance to see something just a little bit different. So this is going to be our last one. One more time, finding the vertex is going to be h and k. In this case, the h is -3 and k is -2. Remember, h does the opposite of what it looks like. If I go to graph that, -3, -2, right there, then I have my axis of symmetry, which is going to be x equals -3. Remember, it always matches the h from your vertex. And I'm going to go ahead and draw that nice little dashed line there to represent the axis of symmetry. And I'm going to go ahead and draw an arrow over here. There it is. Fantastic. And then this one, my a value is negative. So this time we're going to have opens down. So when I go to graph one more time, I still just need one more point. I'm going to still pick something close to the -3. So I'm just going to pick -2. So here's -2. Excuse me. And I'm going to plug this in. So I have y equals -2 times -2 plus 3 squared minus 2. A lot of 2's in this one. All right, so I get -2. Remember, parentheses first. So -2 plus 3 is 1. Then following order of operations, I would square it before I multiply. So I would have -2, and then 1 squared is 1. And then if I keep going, -2 times 1 is -2 minus 2. I end up with y equals -4. So the ordered pair I'm graphing is -2, -4. All right, so then I'm going to match that up on the other side of the axis of symmetry. And you can see this time, remember, opens down, so it's going to be a U shape going, well, let me try that one more time. It's going to be a U shape going down. So something like this. Well, that right side came out a lot better. Let me try the left side again. And that is graphing parabolas in vertex form. Make sure to double check Google Classroom for your assignment. And that's it for today.